The derivative from a numerical, algebraic, and graphical viewpoint. The instantaneous rate of change of f of x at x equals a is defined as f prime of a equals the limit as h approaches 0 of f of x plus h minus f of a divided by h, assuming that that limit exists. The quantity f prime of a is called the derivative of f of x at x equals a. Finding the derivative of f is called differentiating f. As an example, we're going to find f prime of 8 if f of x is equal to 5x squared minus 85x plus 1,762. So f prime of 8 is equal to the limit as h approaches 0 of f of 8 plus h minus f of 8 divided by h. That's equal to 5 bracket 8 plus h squared minus 85 8 plus h plus 1762 minus 5 times 8 squared minus 85 times 8 plus 1762, all divided by h. Simplifying and collecting like terms, we end up with negative 5h plus 5h squared over h. Which is the limit as h approaches 0 once we divide out the h's of negative 5 plus 5h, and applying the limit, this derivative at x equals h is equal to negative 5. Another example, we want to find f prime of 9 if f of t is 50 plus 0.1 t to the 4. So f prime of 9 is the limit as h approaches 0 of f of 9 plus h minus f of 9 divided by h. This is the limit as h approaches 0 of 50 plus 0.1 times 9 plus h to the power of 4 minus 50 plus 0.1 times 9 to the 4 divided by h. Expanding out the brackets, combining like terms, we get the limit as h approaches 0 of 0.1 h to the 4 plus 3.6 h cubed plus 48.6 h squared plus 291.6 h, all divided by h. Dividing out the common h, we get 0.1 h cubed plus 3.6 h squared plus 48.6 h to the power of 1 plus 291.6. Now as h goes to 0, the first three terms are all going to go to 0, and we end up with 291.6. I want to talk about tangent lines. The slope of the tangent line through the point on the graph of f, where x equals a, is given by the instantaneous rate of change or the derivative. So the slope of the tangent line is the same as the instantaneous rate of change. It's the same as the derivative. It's the same as f prime of a. It's the same as the limit as h goes to 0 of f of a plus h minus f of a divided by h. For example, we want to find the equation of the tangent line to f of x equals 5x squared minus 85x plus 1,762 at the point x equals 8, y equals 1402. And we worked out the derivative at x equals 8 in the previous question. It was negative 5. So to construct a straight line, use the equation y minus y1 equals m times x minus x1, where m is the slope, x1 and y1 are the given point. So we get y minus 1402 is equal to negative 5x minus 8. Another example, we're given a graph of p. In this example, we want to draw the derivative So looking at this graph, we can see that we've got a slope that kind of looks like this. The tangent slope sort of looks like that. And then as it gets up here, sort of the same, and then it's getting a little bit less here. So it's not very slopey, and then it gets quite slopey, and then it starts to back off and get less slopey here. So the derivative is going to look something like this. So a little slope, a little bit more, a little bit more, a little bit more, and then around 4, it's got that pretty good slope to it. After 4, the slope starts to get a little bit smaller, a little bit smaller, a little bit smaller, and it gets quite small as we get to 14. Some functions are not differentiable. For example, f of x equals absolute value x is not differentiable at 0. When x is greater than 0, the limit as h approaches 0 of absolute x plus h minus absolute x divided by h is equal to x plus h minus x over h, which is the same as the limit as h approaches 0 of h over h, which is 1. When x is less than 0, the absolute value of x plus h is going to be less than 0. So that limit is going to be negative of x plus h minus negative x divided by h. So we end up with the limit as h goes to 0 of negative h over h, or negative 1. When x is equal to 0, the limit does not exist then, because the limit from the left is different from the limit from the right. We have the graphs of y equals absolute value x and the derivative. So you can see to the left of 0, the slope is negative 1. To the right of 0, the slope is again constant at positive 1. And so the graph of the derivative, essentially the graph of the slope, is going to be piecewise and linear at negative 1 for x is less than 0 and positive 1 for x is greater than 0. So in general, when is a function not differentiable? Well, it's not differentiable if it's got a corner, if it's got a discontinuity, or it's got some sort of vertical tangent. We note that any differentiable function is continuous, but the reverse is not true. As in the case of f of x equals absolute value x, we have a continuous function which is not differentiable. We end here with some different notations for the derivative. We could talk about f prime of x, or y prime, or dy dx, or df dx, or d over dx of f of x, or big D f of x, or d sub x of f of x. All of these notations mean the same thing. They're all notations that are meant to talk about the rate of change of y with respect to x, or a change in y over a change in x, or a change in f over a change in x. And again, we say that a function f is differentiable at a if f prime of a exists. If f prime exists for all a on a particular interval, we say that f of x is differentiable on that interval.